Alright, so let's continue on with 3.6. Let's do the problems that are in on WebAssign. These are similar to the one you'll see in your WebAssign homework assignment. First set of questions deal with 2 up to 26, deal with just differentiating the function. So g of t equals ln of this, so it's 1 over this times the derivative of that. X ln of x, you're going to use the product rule, and when you take the derivative of ln, it's 1 over x. Sine ln of x, derivatives, this is a chain rule, so you can take the derivative of the outside and not touch the inside, and then follow it with the derivative of the inside. Then here again, the derivative of this is, well actually they rewrite it using logarithmic rules, bringing the exponent out front. So you can leave the 2 out front and take the derivative of ln of sine of x is 1 over sine x times the derivative of sine x. 1 over ln of x is ln of x to the negative 1, so you can bring the negative 1 out front, subtract 1 from the exponent, and then you follow with the derivative of ln of x, which is 1 over x. Again, you can break this guy up using logarithmic rules, and you eventually get to this point here. So the derivative of ln of x is 1 over x, derivative of 2x is just 2. This guy, you can write this as an exponent 1/2, and you can bring the 1/2 out front. And now when you take the derivative, the 1/2 is out front, and you say 1 over this guy times the derivative of that guy. Log of secant is 1 over secant times ln of base 10, because it's not base e, it's base 10, times the derivative of secant. Ln of s is 1 over ln of s times the derivative of s, which is 1 over s. This one is 1 over itself times the derivative of itself. So e to the x squared plus ln of x is e to the x squared times e to the ln of x. And e to the ln of x is just x. So this is just x times e to the x squared. And that's the product rule. Okay. Log base 2 of x, log base 5 of x, this is 1 over this times the derivative of that, which is the product rule again, and you got to use the product rule with logarithms there. The next type of question is 29 and 32, where they ask you to take the derivative twice. So you take the first derivative and you simplify it down, and then you take the derivative of that and you get y prime, y double prime. And the same thing here, you're just doing the derivative twice in order to find the second derivative. Nothing new there. These two are a bit tricky, 33 and 35. They ask you to find the derivative, and that's not too bad, but the hard part is finding the domain of the function. So remember, ln of x, whatever's in here has to be greater than 0, because you can't take natural log of 0. It's got to be positive. So we force what's in there, x minus 1, to be positive, or in other words, x has to be greater than 1. But we also have to worry about this denominator equaling 0, so we force this guy to not equal 0. And when we solve that, we get ln of x cannot equal 1, or e to the 1 cannot equal x minus 1, or finally, x cannot equal 1 plus e. And so now, it can't be 1 plus e, but it's also got to be greater than 1, so 1 to 1 plus e union 1 plus e to infinity. And this one, when you take the derivative, you get 1 over this times the derivative of it, and you get that guy there. But you've got to remember for your domain here, this guy has to be greater than 0. And when you do this, this is a nonlinear inequality, and you should set this thing equal to 0, divide up your number line into regions, check the sign of each region, and pick the appropriate regions, and you'll come to this conclusion right there. There's one question where they ask you to find f prime of 1, so first find f prime, so take the derivative of this guy, and then just plug in a 1 for the function itself. Finding the equation of a line, tangent line, this is nothing new to us. We take the derivative, we get our answer, then we plug in 3 for x, and we simplify it down. And once you know your slope and you got your 1 point, you got your answer. Here we take the derivative, and then we plug in 1 for x, and we get 1 as our slope, and 1, 0 is our point, and there we can find our equation of the line. Now 45 and 46, these use logarithmic differentiation done implicitly. So before you take the derivative, you take natural log of both sides. So y becomes natural log of y, and this becomes natural log of this whole thing. These two things multiplied break up into addition, and each of their exponents come out front. And now when you take the derivative of each part, it's a lot easier. This is just 1 over y times the derivative of y. This is 1 over x squared plus 2 times the derivative of x squared plus 2. This is 1 over 4 times 1 over x to the 4th plus 4 times the derivative of x to the 4th plus 4. And when you solve that, you get down to here, and at some point you have to multiply by y to get rid of the 1 over y. And we know what y equals. It's this original guy here, so you put that in place of y, and now you've got your answer. Same thing with 46. We're going to take the natural log of both sides, and this division becomes subtraction, and the multiplication up top becomes addition, and each of these exponents can come out front. Notice they use absolute value bars here because when you're no longer squaring it, it could be negative, and you can't have natural log of a negative number. Alright, so you take the derivative, and you don't have to worry about the absolute value anymore. You take the derivative, and then you multiply by y, and then you replace y with what it equals above, and you got your answer there. Sine inverse, we're going to use our inverse trig function rules, and if you can refer to that, sine inverse, remember sine inverse of x is 1 over the square root of 1 minus x squared. But since it's not x but 5x, you put a 5x in for x, and you have to take the derivative of the 5x, which is just 5. And so you get this answer here. This one, again, we know the formula for tan inverse of x, not tan inverse of the square root of x minus 1. So in place of what you would put x, you put square root of x minus 1 and follow it with the derivative of the square root of x minus 1. This one you're going to have to use the chain rule, so you're going to have to bring the 2 out front and subtract 1. And then you got to follow that with the derivative of tan inverse, which we know what it is. And then when you simplify it, you get this as your answer there.